Hello, everyone. I'm Jan Dutton, the CEO of Prescient Weather, the makers of CropProphet and the World Climate Service. Every grain trader has a story about leaving the office on Friday for a relaxing weekend, having just reviewed a benign weather forecast for the week ahead. But when they show up to the office on Monday morning, the forecast for the week has changed over the 72 hours since they've left the office, and their position is ruined. Has this happened to you? Wouldn't it be great if you could get a sense of what the ECMWF medium range forecast will be when you show up to the office on Monday morning? Today, we're introducing a video series for this summer to complement our CropProphet grain weather trading services. It highlights the U.S. grain market weekend forecast of the forecast. There will be 2 videos per week. The first is on Friday morning, and it will forecast what next Monday morning's ECMWF 1 to 7 day and 8 to 14 day lead temperature and precipitation forecast will likely be. The second video will be released on Monday mornings and will review what the forecast is and how it compares to the Friday forecast of the forecast outlook. The video series starts on Friday, May 30th. So add an appointment to your calendar, subscribe to our channel, or do whatever you need to do to not miss the video series. In today's video, we're going to review how this is possible. It covers the science and the applications that make the U.S. grain trading forecast of the forecast possible. I hope to be very clear. Our goal during the Friday video is to provide a probabilistic outlook of what Monday's ECMWF medium range forecast is going to be. This is the weather forecast model widely followed by grain markets. The goal is to enable grain traders to assess the weather risk in their current positions before you go home for the weekend. The outlook will be probabilistic, enabling you to evaluate the risk of different ECMWF model forecast outcomes by Monday morning. There are 2 key ECMWF models at play. The ECMWF Integrated Forecast System, otherwise known as the Euro, is the high-resolution medium-range model the ECMWF uses for 15-day forecasts. It updates twice daily. The ECMWF Extended model updates once per day and forecasts as much as 46 days into the future, but with a lower resolution. We use both models in our CropProphet and World Climate Service products. And to create the forecast of the forecast analysis, we're going to use the information from both products and both models. Most users of weather forecast information are not aware that the modeling centers make reforecasts available. Reforecasts are exactly what the name implies. The centers run the current version of the model, but for prior dates. The ECMWF is the most advanced provider of reforecast data. They release a reforecast for one initialization month and day of month for the prior 20 years on every odd day of the month. That's a mouthful. Let's take a look at this graphic. It shows that for Friday, May 23rd, 2025, the ECMWF released an ECMWF Extended Model Reforecast for May 23rd, 2024, and May 23rd, 2023, and so forth all the way back to May 23rd, 2005. They provide 20 years of forecasts for the same month and day, but for different years. The reforecasts are a crucial data source for enhancing the value of the extended forecast information. That is achieved through calibration. Forecast calibration has 2 goals. The first is bias correction. Everyone knows weather forecasts are not perfect. Bias correction allows us to improve persistent forecast errors that arise from the model's imperfections. The bias of the model is measured by calculating the average weather over the 20-year reforecast, which is called the model climatology. The model climatology is compared to the observed climatology, which is what actually happened over the 20-year period. Any differences between the model and the observations are removed from the real-time forecasts. This step is called bias correction. We show here an example of how bias correction changes the ECMWF medium range forecast with content from the World Climate Service. Notice how on the right-hand side, the bias corrected forecast, the areas of colder than normal temperatures are much smaller than on the left-hand side, the unbiased corrected forecast. The second step in improving the forecast is improving the forecast of uncertainty. Modern physics-based weather forecasting creates an ensemble forecast. To start running a weather forecast, we have to estimate the current state of the atmosphere from available instantaneous observations. These include weather station data, weather balloon data, satellite information, and other data sources. But we can't know what's going on everywhere in the world at the same time perfectly. The atmosphere is a nonlinear dynamical system. That's a complicated way of describing the butterfly effect that you may have heard of. It means that minor differences between our estimates of the current state of the atmosphere and what is actually happening when we start the forecast model is why weather forecasts become increasingly less accurate with forecast lead time. That's why a 3-day forecast is much more accurate than a 10-day forecast. To address this uncertainty, the modeling centers start the weather model once with the best estimate of the current state of the atmosphere. Then another forecast is started with the initial conditions tweaked ever so slightly. The forecast of the second run becomes different than the original run over forecast time. In the case of the ECMWF extended model, this process is repeated another 99 times, creating a 101-member ensemble forecast. Each forecast scenario is equally probable to occur. The forecast chart showed here of U.S. corn production weighted temperatures illustrates an example of the ECMWF extended ensemble forecast. Notice how the forecasts all agree early in the forecast period, but then diverge over time after the models warm up. That divergence is the forecast uncertainty. And just as forecast models don't forecast the weather perfectly, they also don't estimate the forecast uncertainty perfectly. The estimates of forecast uncertainty are improved by comparing the forecasts in the 20-year reforecast data to what actually happened. The uncertainty of the forecast, represented by the spread of the ensemble forecasts at each lead time, is adjusted to better reflect the actual variability of the weather conditions that occurred. The result is a probabilistic forecast. The ensemble data is transformed into a forecast of the probability of specific events occurring. The events refer to the probability that conditions, such as temperatures or accumulated precipitation, will be normal, near normal, or below normal. And the benefits of ensemble forecast calibration are that the forecasts become reliable. This means that the probability of the event being forecast will occur with that frequency in the real world. So when the calibrated ECMWF extended model forecasts the temperature for a week ahead to be above normal with a 60% chance, it will happen 60% of the time. Okay, we've covered the weather forecast models that we're going to discuss. We've covered the benefits of bias correction and how it's used in calibration. Now we're going to discuss the secret sauce that makes the forecast of the forecast possible. One reason why calibration works is that forecast days are averaged together. Doing this helps to cancel out noise and extract the signal in the forecast. A normal calibration period in a subseasonal forecast is 7 days, so it's logical that we'd average the first 7 days of the forecast to create a 1-week lead forecast, and then the next 7 days to create a 2-week lead forecast, and so on until you reach the end of the forecast period. The little twist that makes the forecast of the forecast possible is that we calibrate the first Monday to Sunday period in the available forecast days, and then the second Monday to Sunday period, and so on to the end of the forecast period. We call this a calendar week calibration. By doing this, we are forecasting the weather conditions of what the coming Monday to Sunday periods are likely to be like. Finally, while the ECMWF medium range and ECMWF extended models are not identical, they are quite similar. We can say they are in the same family of physics-based weather forecast models. And so the final connection to make is that the ECMWF extended calendar week calibrated forecast is both a forecast of the weather for that calendar week, but it's also a forecast of what the ECMWF medium range model is going to be on Monday. Let's look at last week's forecast of the forecast. We see for the ECMWF extended model for the Thursday run available Friday morning, the 1 to 7 day forecast of the Monday to Sunday forecast showed increased chances of colder than normal temperatures across the northern part of the United States and increased chances of warmer than normal temperatures across the southern part of the United States. Now remember, this is a forecast of what the ECMWF medium range forecast models will look like on Monday morning. So let's take a look at that forecast. We see colder than normal temperatures being forecast across the northern part of the United States and warmer than normal temperatures across the southern part of the United States. We can also do this for what will be the 8 to 14 day forecast. In this case, the ECMWF extended model was showing increased chances of colder than normal temperatures across much of the eastern and northeastern United States and warmer than normal temperatures across the western United States. Then on Monday morning, the actual forecast was released, and we see colder temperatures across the eastern United States and much of the northeast United States, and warmer temperatures across the western United States. So in our Friday and Monday CropProphet Forecast of the Forecast video series, we're going to be using these concepts and capabilities to forecast on Friday what Monday's ECMWF medium range forecast will likely be. It will give video watchers a leg up on possible market-moving forecast changes before the weekend even begins. Of course, if you want this information before we release the videos on Friday and Monday, there are always subscriptions to CropProphet and the World Climate Service available. To get started with a trial of the products, simply use the link below to get started. So subscribe to the CropProphet YouTube channel, and remember that these videos start on Friday, May 30th. Thank you very much.